For number 5 here, we're going to start by finding the relative minima and maxima. So that's wherever we change from increasing to decreasing or vice versa. So in this case we have two locations. -2, -4 would be a relative minimum, and 0, 0 would be a relative maximum. So now when we talk about intervals of increasing and decreasing, we always are going between those points, either to those points or from those points, and that in between those points are our increasing and decreasing intervals. So in this case, from left to right, notice that here the graph is decreasing. So we always report the domain when we're given these intervals. So the domain for this first decreasing would start at -infinity, and it stops when x gets to -2. Then it starts decreasing again right here at the origin. So when x is 0, that's when it starts decreasing again, and it would continue decreasing as x moves to infinity. So those would be the two intervals of decreasing. Then for increasing, we are increasing in between those 2 points. So we are increasing starting when x is -2, and we increase until x gets to 0. So those would be the intervals of decreasing and increasing. Remember that we're just reporting the x values, not the y values. The x-intercepts we can approximate to be right here at -3, 0, and at the origin 0, 0. The domain of the entire function is going to be all real numbers, or -infinity to +infinity, and all polynomials have that domain. Range-wise, if we look at our graph, we're looking at the different y values. We say the lowest y value up to the highest, which in this case, if you look at the graph, it spans the whole y-axis. So in this case, our range is also all real numbers, -infinity to +infinity. And then end behavior. As x approaches +infinity, y is, well, let's see. So as x moves to the right, notice that the function is going down. So as x approaches +infinity, y is approaching -infinity. Then we also want to know what happens as x approaches -infinity, or as x moves to the left, we see that our graph here is moving up. So y would approach +infinity. We could also tell that based on the leading term. So since it was an odd degree, we knew that one side was going to go up and one side was going to go down. And since it was a negative leading coefficient, that means that our shape was something like this, where our function started up and then went down over time, because it's like having a negative slope.